You think the day we first saw a black hole shadow was a triumph of photography? A camera? A picture? A dark thing finally caught in the act? No, that's not what happened. What you're actually remembering is the day your intuition officially lost its last appeal to physics. Because a black hole is not an object you can photograph. Not because it's mysterious, not because it's dangerous, but because it doesn't cooperate with the rules your brain uses to define seeing. You were told we saw the shadow of a black hole. You assumed that meant a silhouette, something blocking light, like an eclipse, like a coin held up to the sun. That sounds right. It isn't. A black hole doesn't cast a shadow the way an object does. There is no surface throwing darkness behind it, no cosmic lamp shining from the side, no edge. What you saw was light failing. Specifically, light attempting to escape a region of space-time that refuses to let straight lines remain straight. And that's already a problem for you, because you assume light travels in lines. You were trained that way. Rulers, arrows, lasers, diagrams. But near a black hole, straight is a nostalgic concept. The shadow isn't the black hole. It's the outline of where light can no longer win an argument with gravity. That ring you remember? That glowing donut that flooded your feed? That's not matter. That's not plasma swirling in a neat circle. That's light from behind the black hole being bent so severely that it wraps around the object and reaches us anyway. Light that should have missed us entirely. Light that took the scenic route through warped space-time. And the darkness in the center? That's not something blocking light. That's a region where light paths terminate. Not absorbed, not extinguished, simply never arriving. You didn't see darkness. You saw missing information. This is where sci-fi usually steps in and ruins the moment. You were primed to imagine a hole in space, a tunnel, a drain, something you fall into. That's storytelling. Physics doesn't do stories. It does measurements. And the measurements say a black hole is not a hole. It's a region where space-time curvature becomes so extreme that all future directed paths point inward, including light, including time. So when people said, "We finally saw one," what they really meant was, our equations survived their most hostile test. Because the size of that shadow, it wasn't guessed, it wasn't tuned, it wasn't artistically interpreted, it matched prediction. Within error bars. That should bother you more than it does. Because it means gravity, under conditions you will never experience, behaves exactly as calculated decades ago by equations written before we had the technology to test them. No improvisation, no surprises, no cinematic flair, just ruthless consistency. And here's another assumption you probably didn't notice you were making, that this image came from a telescope in space. Of course it didn't. You can't build a lens big enough to see something that small at that distance. So instead, we did something far less intuitive. We turned Earth into the telescope. Multiple observatories across the planet synchronized their clocks with atomic precision, not to take a picture, to record interference patterns, timestamps, phase data. There was no shutter click. There was math. Months of correlation, calibration, error correction, algorithms grinding reality down into something compressible. The final image wasn't captured. It was reconstructed, which means the picture you saw is not a snapshot. It's a statistical argument, a visual proof that space-time does what space-time is supposed to do when pushed to its limit. Nothing crossed the event horizon to make that image. No signal escaped the interior. No light carried secrets from within. Everything you saw came from the outside, and that's the point. Black holes are not observed directly. They are inferred with extreme confidence. Gravity tells on itself. You don't watch the criminal. You examine the crime scene, the orbiting gas, the Doppler shifts, the lensing, the missing photons. This is how astronomy actually works, and it's deeply offensive to common sense, because you want edges. You want surfaces. You want something to point at and say, there, that's it. The universe does not respect that desire. It gives you gradients, probabilities, curved geometries, effects without accessible causes. And the shadow size drives that home brutally. No matter how fast the black hole spins, no matter how much mass it has, within a certain range, the shadow barely changes. The event horizon can flatten, stretch, rotate, but the shadow stays stubbornly similar. Why? Because the shadow isn't the horizon. It's defined by photon orbits, light trapped in unstable loops, circling the black hole multiple times before either escaping or surrendering. You're not seeing where matter ends. You're seeing where paths stop being survivable. That should rewire how you think about space, because space is not a stage. It's not empty. It's not passive. Space bends. Time slows. Paths curve. Signals delay. And this isn't exotic physics reserved for monsters at galactic centers. This is the same framework that corrects satellite clocks so your navigation works at all. The black hole just turns the volume knob to maximum. Which brings us to the real mistake people made that day. They thought the mystery was solved. They thought the image was closure. It wasn't. It was confirmation that our understanding fails exactly where we predicted it would fail and nowhere else. The interior remains hidden, permanently, not technologically, fundamentally. No upgrade fixes that, and that should unsettle you, because it means there are regions of reality that are not just unknown, but inaccessible in principle. Physics allows them. Measurement forbids them. That tension is not a bug. It's the rule. And once you accept that, you start to realize something uncomfortable. If your intuition collapses this badly around a black hole, an object predicted, modeled, and confirmed, what chance does it have anywhere else? You assume your intuition fails near black holes because black holes are extreme. That's comforting. It lets you believe the rest of the universe still behaves politely, that gravity only gets weird at the edges, that space-time mostly plays by the rules you learned in high school, except in a few dramatic locations we warn you about in advance. No. Your intuition doesn't fail there. It fails everywhere. You just don't notice because Earth is a low-stress environment for physics. A gentle neighborhood, flat spacetime by cosmic standards, gravity turned down to a whisper, time flowing almost uniformly enough that your brain never has to question it. Almost. Let's scale up slowly, because this is where people usually cheat. You think time passes the same for everyone. You were told that clocks tick universally. Seconds stack neatly. Yesterday becomes today becomes tomorrow. That feels foundational. It's wrong. Time is local. Always has been, always will be. And the moment you leave Earth's surface, that fact stops being philosophical and starts being measurable. Your GPS works only because engineers do violence to your intuition. Satellites experience weaker gravity than you do. Their clocks tick faster, not metaphorically, not as if, faster. If we didn't correct for that, your location would drift kilometers per day. That's not speculation, that's engineering reality. Same equations, same space-time, same rules that govern black holes, just less dramatic. Which is the first crack in the myth. Extreme physics isn't separate physics. It's regular physics with the consequences exposed. Now stretch that idea. Imagine a planet more massive than Earth. Gravity stronger, time slower at the surface. You stand there watching a ship lift off. As it climbs, its clocks begin to outrun yours. You don't feel time slowing. You never do. Each observer experiences their own clock as normal. That's the trap. Relativity never feels strange locally. It only becomes strange when you compare notes, which humans are terrible at. Now add speed. You were taught speed adds. Walk on a train, throw a ball, velocity stack. Simple. Except they don't. At high speeds, time itself absorbs the discrepancy. Space contracts, durations stretch, cause and effect negotiate terms. Again, not as a theory, as measurement. Particles in accelerators live longer than they should. Muons survive trips they have no business surviving. Equations predict it. Detectors confirm it. Your intuition objects. Physics ignores the objection. So when you imagine falling toward a black hole, you probably picture acceleration, panic, maybe a scream cut short. From your perspective, time continues. You cross thresholds. Physics unfolds normally, locally. But to someone far away, watching your descent, you slow. Not figuratively, visually, temporally. Your clock drifts behind theirs. Signals redshift. Motions stretch. You asymptotically approach the horizon. never quite crossing it within their frame. This isn't a paradox. It's a bookkeeping problem caused by insisting on a universal now. There isn't one. Time is not global. Space is not rigid. Events do not agree on order once gravity and speed intervene. And this isn't limited to black holes. They just make the failure obvious. Even the universe as a whole participates. You probably think of the cosmos as expanding into something, space ballooning outward, galaxies flying away through a static backdrop. That image is intuitive and wrong. Space itself expands. Distances grow without motion. Galaxies aren't racing through space. Space is stretching between them, which means there are galaxies receding from us faster than light, not because they're breaking rules, but because the rules you imagine don't apply globally. Relativity doesn't care about your need for a cosmic speed limit in every context. It cares about local measurements. Again, local comfort, global chaos. And here's where intuition really collapses. You assume cause always precedes effect in a clean, ordered way, that time's arrow is universal, that entropy gives you a direction. Mostly true, until space-time curvature tilts the axes. Near massive objects' paths through space-time can curve so dramatically that what one observer calls before, another calls after. Light cones tip, horizons form, communication becomes asymmetric, information can leave but never return, or arrive without reply. Black holes are just the cleanest demonstration of this asymmetry. They draw a hard line through space-time and say, beyond this, your concept of simultaneity is meaningless. And that's the deeper failure you're meant to notice. Your intuition assumes the universe is organized for observers. It isn't. It's organized for consistency. Equations don't privilege perspective. They don't care about narrative. They don't pause to make sure events line up neatly for human understanding. They describe what survives comparison across frames. Everything else is a convenience. Which means when you ask, what really happens? You're often asking the wrong question. There is no single story that satisfies all observers. There are only relationships between measurements. That's the price of accuracy. So when you look back at that black hole shadow, understand what it actually represents. Not a photograph, a warning. A warning that the universe does not owe you intuitive explanations, that your sense of time, space, motion, and causality evolved for survival on a warm rock, not for navigating curved space-time. And if your instincts fail at planetary scales, fail at orbital scales, fail at relativistic speeds, what do you think happens when we push even further? Because gravity has one more trick, and it doesn't just bend space and slow time. It can tear the very concept of before and after apart. You think black holes are where physics breaks. That's the popular line, the safe one. It lets you imagine the universe behaving sensibly almost everywhere else, with a few outlaw zones we can politely fence off and label mysterious. That's backwards. Black holes are where physics stops pretending to be intuitive. They don't break the rules. They expose which rules were never real to begin with. By the time you reach the edge of a black hole, space is no longer something you move through. It becomes something that moves you. Every possible future points inward, not metaphorically, geometrically. This is where language starts lying to you. You hear event horizon and picture a surface, a membrane, a glowing boundary you cross like a finish line. No, there is no marker, no shock, no signpost. Locally, nothing special happens at that boundary. Atoms behave, forces work. Your body doesn't notice, which should terrify you. Because it means the most important boundary in space-time is invisible to the thing crossing it. The horizon is not defined by what happens there. It's defined by what becomes impossible after. After crossing it, there is no path that leads back out. Not because something blocks you, because space-time itself no longer contains such a path. This is not falling into a pit. It's time pointing inward. Inside the horizon, future is a direction, not a moment. And that direction leads to a singularity, not as a place you arrive, but as a fate you cannot avoid. This is where your intuition collapses completely. You want to ask what the singularity looks like. What exists there? What happens at the center? That question assumes center still means something. It doesn't. The singularity is not a location in space, it's a boundary in time. A termination of world lines, the end of causal structure. And no, this isn't poetic language. It's what the equations say when extended honestly, which is exactly why physicists don't like singularities. Not because they're spooky, because they signal incompleteness, a place where our descriptions stop working. Not observations, descriptions. And that's crucial, because we don't get to peek inside and check. The event horizon enforces a strict accounting rule. No information from within may influence the outside universe, ever. That's not a technological limitation. It's not waiting on better telescopes. It's baked into the geometry, which creates a problem you've probably never considered. If information can't escape, but black holes can evaporate, slowly, over absurd stretches of time, what happens to the information that fell in? Does it disappear? That question detonated decades of comfortable thinking. Because physics has another rule. Information is not supposed to be destroyed. Not in quantum mechanics. Not ever. So something has to give. Either black holes erase information, or our understanding of space-time, quantum theory, or both is incomplete. There is no third option. This is not science fiction. This is an internal accounting crisis within physics itself, argued with equations, not metaphors. And notice what's missing from that debate. Human intuition. It has nothing to contribute here. Now widen the lens. Black holes are not rare cosmic accidents. They're common. Galaxies are built around them. Stellar mass ones litter the universe. Supermassive ones anchor structure on the largest scales. They influence star formation, galactic evolution, the distribution of matter across billions of light years. They are not glitches. They are features. And then there's dark matter. You've heard the name. You probably imagine invisible stuff floating around, occasionally bumping into galaxies like cosmic fog. That's another intuition fail. Dark matter doesn't clump like normal matter. It doesn't shine. It doesn't cool. It doesn't collapse into stars or planets. But it gravitates. And we know it's there not because we see it, but because galaxies rotate too fast, clusters bend light too strongly, and large-scale structure forms in patterns that visible matter alone cannot produce. Again, inference, not observation. Missing mass, not mysterious glow. Which means most of the universe is composed of something you will never see directly, interacting primarily through the same force that creates black holes. Gravity. The weakest force. The most dominant architect. And gravity doesn't care about your categories. It doesn't distinguish between matter and energy, between space and time, between past and future when curvature becomes extreme. It simply shapes the arena, which brings us back to that first image. That black hole shadow wasn't just a triumph of collaboration or technology. It was a boundary marker, a line saying, beyond this, even our best concepts start to fray. Not because reality becomes mystical, but because it becomes too consistent to tolerate comforting shortcuts. Understanding the universe does not mean visualizing it. It means accepting descriptions that resist visualization. It means letting go of the demand that reality makes sense on human terms. And if that feels unsettling, good. Because the universe is not obligated to align with how you want it to work. It only answers to measurement. And what measurement tells us, over and over, is that the deeper you go, the less your instincts matter. Which leaves one final question. If black holes expose the limits of space, time, causality, and information, what does that say about your place in a universe that runs perfectly fine without your understanding? You keep looking for a takeaway. Something stabilizing. Something that puts you back in control. That instinct is the last one to go. Because the real lesson of the day we first saw a black hole shadow is not about black holes at all. It's about you, specifically, about how badly equipped you are to judge reality without instruments. You assumed the universe would reveal itself visually, that if something mattered enough, you'd be able to see it, outline it, point to it. Instead, the most honest image ever released in astronomy was an absence defined by equations. A hole outlined by what failed to arrive. That should recalibrate your expectations. You are not living in a universe that wants to be understood intuitively. You're living in one that tolerates understanding only through relentless comparison, correction, and humility. Your senses evolved to avoid cliffs and find food, not to parse curved spacetime. Your intuition is a survival tool, not a truth detector. And physics keeps proving that, patiently, without malice. Every time you think you've grasped the big picture, measurement comes along and quietly deletes a comforting assumption. You thought space was empty. It isn't. You thought time was universal. It isn't. You thought seeing meant knowing. It doesn't. You thought extreme objects were rare exceptions. They're structural. Even your idea of now is parochial. The universe does not agree on simultaneity. There is no cosmic present slicing cleanly across galaxies. There are only local clocks, ticking along world lines, each valid in its own frame and irrelevant everywhere else. Reality is not synchronized for your convenience. And that black hole shadow sits right at the intersection of all of this. It is a monument to indirect knowledge. Nothing about it rewards imagination. Everything about it rewards discipline. No one involved asked what a black hole should look like. They asked what space-time must do under known conditions, and then they checked. And the universe answered, not with drama, with compliance, which is somehow more unsettling, because it means there is no narrative arc here, no rising tension toward human significance, no guarantee that deeper understanding leads to comfort. Often, it leads to the opposite. You are not central. You are not early. You are not late. You are not especially relevant to the machinery you're trying to comprehend. Black holes will continue forming, merging, evaporating, and shaping galaxies whether or not anyone is around to argue about them. Dark matter will continue sculpting large-scale structure without ever announcing what it is. Space-time will continue bending, stretching, and redirecting causality with no regard for how confusing that feels to you. And the universe will remain perfectly coherent while remaining partially inaccessible. That's the part people resist. They want to believe the unknown is just the not yet known. That with enough time, enough funding, enough cleverness, every door opens. Physics disagrees. Some doors are load-bearing. Remove them, and the structure collapses. Event horizons are not puzzles waiting to be solved. They are boundaries enforced by consistency. You don't beat them, you work around them. So what does it actually mean to understand the universe? It does not mean visualizing everything. It does not mean having a story for every phenomenon. It does not mean reducing reality to human-scale metaphors. It means knowing which questions are allowed. It means knowing where inference ends and imagination begins, and refusing to confuse the two. It means accepting that some regions of reality can be described precisely without ever being experienced or observed directly. That's not a failure of science. That's its strength. The image of the black hole shadow did not bring the universe closer to you. It pushed it farther away by showing you just how much of reality operates perfectly well without needing to make sense to you at all. And that's the final reframe. You don't live in a universe designed for comprehension. You live next to a universe that permits comprehension only when you abandon the idea that your intuition deserves a vote. The moment you accept that, something shifts. Not comfort, clarity. You stop asking why the universe behaves this way, and you start asking how much of it can be constrained, tested, and survived by equations alone. That's not a warm conclusion. It's a precise one. And precision, in a universe like this, is the only honesty available. Because the day we first saw a black hole's shadow wasn't the day we finally saw into the darkness. It was the day we proved, beyond reasonable doubt, that the darkness doesn't need us to understand it. It just needs us to measure carefully and stay out of the way.